China's remarkable achievement in the field of nuclear fusion has made headlines recently, with the country's artificial sun, or experimental advanced superconducting tokamak, EAST, breaking its own record for sustaining high-temperature plasma for an extended period. This feat represents a major step forward in humanity's quest to replicate the process that powers the sun, potentially revolutionizing the way we generate energy on Earth. In this video, we'll delve into the details of China's artificial sun and what this new record means for the future of energy production. To understand the significance of China's record, it's important to first grasp the science behind nuclear fusion. Nuclear fusion is the process in which two hydrogen atoms combine to form a heavier element, releasing a vast amount of energy in the process. This is the same process that occurs within the core of stars, including our sun. For decades, scientists have been working to recreate this process on Earth, hoping to harness fusion as a clean, virtually limitless source of energy. However, achieving sustained nuclear fusion at the scale necessary for practical energy generation has proven incredibly challenging. One of the main hurdles in achieving nuclear fusion is the extreme conditions required. For fusion to occur, the temperature of the plasma, the hot electrically charged gas made up of ions and free electrons, must reach millions of degrees Celsius. At these temperatures, the plasma is far too hot to be contained by conventional materials, which is why advanced magnetic confinement methods are used. This is where China's EAST facility comes in. The EAST reactor is designed to create and maintain these ultra-high temperature plasma conditions by using powerful magnetic fields. The magnetic fields keep the plasma confined and stable, preventing it from touching the walls of the reactor. This allows the fusion process to occur, albeit for brief moments. The ultimate goal is to keep the plasma stable long enough to produce more energy than is required to sustain the reaction, an achievement known as net positive energy. In December 2022, EAST set a new world record by keeping its plasma heated to over 158 million degrees Fahrenheit, 70 million degrees Celsius for a record-breaking 1,056 seconds, just under 18 minutes. This is an extraordinary achievement in itself, as it demonstrates the growing capability of the facility to maintain the extreme conditions necessary for fusion. Now, the recent breakthrough takes this achievement even further. In the most recent tests, the EAST reactor achieved a significantly longer period of stable fusion reactions. This improvement represents a major milestone in the progress toward making nuclear fusion a reliable and sustainable energy source. China's successful experiment has far-reaching implications for the future of energy production. As the global community seeks alternatives to fossil fuels, nuclear fusion could become a game-changer by providing a clean, virtually inexhaustible supply of energy. The Chinese government has long been committed to advancing its nuclear fusion capabilities. The EAST facility, which is located in Hefei, Anhui Province, has become a focal point of China's energy research efforts. The country's ambitions in this area have been fueled by both scientific curiosity and the need to address its growing energy demands. Fusion energy has the potential to offer a solution to many of the world's energy and environmental problems, including climate change. Unlike nuclear fission, which is the process used in traditional nuclear power plants, fusion does not produce dangerous radioactive waste or carry the same risk of catastrophic accidents. In fusion reactions, the byproducts are typically harmless elements like helium, which is a non-toxic gas. This makes fusion energy an incredibly appealing option for the future, as it would help to mitigate the environmental and safety concerns associated with current energy sources. China's efforts are not isolated. Other countries, including the United States, the European Union, and Japan, are also heavily invested in fusion research, with the International Thermonuclear Experimental Reactor, ITER in France, being one of the most ambitious global projects in this area. However, China's advancements are setting new benchmarks, and their success with EAST is positioning the country as a leader in fusion research. The implications of sustained nuclear fusion could extend far beyond energy production. If successful on a commercial scale, fusion reactors could provide the energy needed to power everything from homes to industries without contributing to air pollution or climate change. Additionally, the technology could potentially be used to develop new types of propulsion systems, providing breakthroughs in space exploration. However, it's important to note that while these breakthroughs are incredibly promising, the road to practical fusion energy is still a long one. The technology is still in its early stages, and there are many challenges ahead. For instance, while the EAST reactor has achieved impressive results, it still requires significant amounts of energy to maintain the conditions necessary for fusion. The ultimate goal is to reach a point where the energy produced by by the fusion reaction is greater than the energy required to sustain it. This would mark the true beginning of fusion as a viable energy source. In conclusion, China's recent artificial sun breakthrough is a significant step in the ongoing quest for nuclear fusion. The country's progress with the East facility demonstrates that sustained fusion reactions are becoming more achievable. As research and development continue, we may soon see fusion energy become a key part of the world's energy landscape, helping to address the global challenges of energy demand and climate change.